Purnima, you can begin.
Yes, ma'am. I'm enabling the live streaming.
Yeah, it is enabled, it seems. Yeah.
Yes, ma'am. Okay, thank you.
Good afternoon, everybody.
Very good afternoon to all. So in today's session, we are going to do an exercise on Yolo V4 for smoke detection. The data set is a large data set with 3000 images, but in this example, we are going to use a part of the data set, and we will start with what we can start with labeling of the data so that all of you will know how the labeling part is done in case of any type of object detection algorithm. So I request you all to please start your Jupyter notebook in your local system. I request you all to please start Jupyter notebook. This is the notebook. I'm starting this Jupyter notebook, TensorFlow GPU. It is enabled in my system. Please start. It will be opening in a new tab like this. Anywhere on your system, just create a new Python 3 notebook. Here we are going to use label IMG tool. That is a labeling tool which saves your data in the for XML format annotation and YOLO based annotations. So this is the tool we use mostly. So we are going to demonstrate it for labeling task. So all of you can install it using pip install label IMG. I'm pasting the code in the chat box. So you can access it. Please run it using pip install label IMG. So I think now the screen is visible to you all. You have to install the package with pip install label IMG. I think all of you are able to install it. Please report in the chat box whether your package is installed or not. You cannot do it in Colab because it will start a new software package in your local system. So that's why you need it to be run in your local system. Okay, so the installation is done in your case. Then to access the data, you have to to access the software and to label the data, you have to run the software. So please write label img. It will pop up a new software window. So this is the window. Is it visible to you all, the software window? Okay, let me reshare. I think now it is visible to you all. I'll restart it. This is the line of the code you have to write in your Jupyter notebook. Exclamation mark, then label img. So it will start a new software. This is the software. Please start in your system. If you are able to do it, report in the chat box that installed successfully, so that we can start the labeling process. Can we proceed further? There is one error in Neha ma'am's system. Could not install the package because of the OS error. So this is because you have not run the Jupyter notebook with admin privileges. So whenever you start software, please do it with admin privileges. It's label img. It is label img. And if you are getting the error that it is not an internal or external command, that means many of you are getting the error, I think so. I'm again pasting the command, both the commands. This is the command pip install label img is the command which you have to run in the Jupyter notebook to install the software. And second is to start the software, you have to just type label img. Please run it. Now I think all of you are able to resolve the error. Please check. If it is done, then we can proceed further. If you are facing the error, you have to check, you have to run your Jupyter notebook with admin privileges. Please run your Jupyter notebook with administrative privileges. So let's proceed further, maybe. So this is the software on which we are going to perform the labeling. I tried with, there are multiple errors you are facing. I have to, I think, re-share.
Can Samir or Shubhangi help them? Those who are
Ma'am, they are getting, yes, ma'am, they are getting the error because of the their Jupyter is not running in admin mode.
yeah, as you told just now. Yeah. So run again, and in spite of that, if you are you're not able to, then maybe one of them can respond to them.
Yes.
Thank you.
Thank you. And I have shared the data set with you all in the chat box. You can see there is wildfire_smoke.zip file is uploaded. Please download it. All of you can access the data wildfire_smoke.zip from the chat box. Are you able to download that zip file? Okay, you are not able to see it. I will re-upload it until I am showing you how you can label your data. I'm re-uploading it. So as the data is quite big, it may take some time. Till that time, let's label the data. So this is the software we are going to use to label the data. It has multiple menus available, like you can open a new file, edit it, and what are the privileges you want in the software. These are the options available. Next is, there are 3 folders available. You can see one is open, one is open dir, and one is in save directory. So I'm opening the directory where all my images are there. I'm going to desktop, and then this is the folder I'm selecting, which will have all the images. I have clicked, opened a new folder which have the images. So you can see this is the image available which we are going to label. This is a camera image taken in the some of the somewhere from the stable camera which has smoke inside the forest. So this is the bounding box we have to create. So for that, you can click on this create react box, and then you can select the area where smoke is present. And then you can write the name of the object it is. So I think this box is visible to you all. This is the box of smoke. And then to save it, you have to click on this save button. It will ask you where you want to save the XML file. I'm saving in the same folder. Another option is you can save it in the form of Yolo. I'm saving in both the format in the same folder. Now let me show you what is there inside the folder. So this is the image we have labeled 13.png. This is the XML file I'm opening. This is the XML file. You can see that it is starting with annotation. It has folder name, file name, path where your file is there, source, width and height, name of the object, minimum value of bounding box, x minimum, y minimum, x maximum, and y maximum. So I think all of you are able to do this. Please write in the chat box if you are able to see. Are you able to create the annotation? In any of the image, are you able to do the annotation? Anyone who is able to do it? Okay, it is working. Someone has written that it is working. Anyone else? Okay, so Shiva ma'am, I think she's asking to repeat it. I'll repeat the same process again. And you people want the data set. You can download the data set from Drive also. I'm pasting the link of the Drive. And I have also uploaded the data from chat box. You can download the data from the shared Drive. I have pasted the link. So it's a quite big data. It consists of some 1300 images. But in this lab, we will try to practice it with around 50 images so that the process will be easier and it will be covering within 2 hours. So I think you can access the data. Please download the Or if you want to work with small size data, what you can do, you can just download 10 PNG file and 10 text file from the shared folder. Then also you can do the same process. If you have limited internet capabilities, then you can go through this process also. So can we go ahead now? If labeling is done, you understood how we can label using label IMG tool. Can we proceed with the code? So I request you all to please open your Google Drive. I will explain how we can go ahead with Yolo annotation. Please create a new Python notebook using Google Collaboratory. I'm renaming it. And the other change you have to do is change the runtime. It is compulsorily to you all to change the hardware accelerator as GPU. Then please mount your if your mounting is done, please report in the chat box mounted. Then we'll proceed with the next step. If you have done the mounting, please report in the chat box. In my case, mounting is done. Now, next step is my drive will be appeared. So you can see my drive has been appeared. When all of you are able to do it, then we will proceed further. Okay, so some 5 to 10 participants can do this. So let's proceed further. Next is we have to change the current working directory as we have done in previous classes. So all I'm going to here ML4CV2022, copying the path and changing the current working directory. And then I'm running ls command. So just download the 10 PNG images and corresponding 10 text file from the shared folder if you have limited internet capabilities. Next is we are going to use Yolo v4 official code, that is darknet, which is developed by LXCAB. So you can access the code from GitHub. And then we can this is the code. Darknet code is this. So to access the code, I'm copying this link. First of all, I'm pasting the URL from where you can access the darknet code, and then I'm just clicking on this code button and copying this link. Or you can search for GitHub LXAB darknet. Then you can go to this particular page. Just copy this and then go to your notebook. Here you have to write git clone and then paste the darknet path. It will take some time and your darknet folder will be downloaded. I'm pasting this code again. You have to write git clone path of the git file which you want to clone. So there is a question, can we use git clone in research work like a PhD research work? So in whenever you are cloning anything from GitHub, then you are accessing someone else's code. So this darknet code is the official code of darknet. You can apply it for your research work, but you have to acknowledge that you are using that particular code. So I think cloning is done for you all. Can we proceed further? After cloning, please comment this git clone command. Please comment it. Why we are commenting? Because if you will rerun this notebook, then this line will cell will run. If you will rerun from this runtime, so sometimes by mistake we reclone it. So that can cause the error. Because of that, whatever commands are needed once in your notebook, after running those commands, we generally comment. So this is a good practice. Please do it. After that, please run ls command to check list of available files and directories in the current working directory. So you can see we have darknet here. We have to go inside this darknet folder, cd space darknet. So now I'm currently inside the darknet folder. Let's see what is there inside darknet. So these are the files and folders available in the darknet folder. Next is, now we have downloaded the code. Next is we have to change some files inside the darknet folder so that it will be compatible with the custom data set. You can use the Yolo v4 for your data set for object detection tasks. So for that, some changes are required. So I think all of you are able to do this part. I'm not getting the response. Can we proceed further? Okay. So next thing is we have to make some changes. The very first change we will make is inside the make file, inside the make file. So to perform the changes, there are two ways. Either you can download this file, or you can perform the changes directly using sed command. You can see make file is there. This is the file. In your case also it is there inside. So many of you are not able to access the data set. I am copying the path again. Please give me a minute. I'm pasting the path of the data set. Meanwhile, if you have any question, you can ask. So it's a quite big data set with 1600 images and 1600 annotations. You can download the entire data set from the link provided. The link is there in the Python notebook. You can access it. I'm sharing it again. Please give me a minute. I have pasted the link is there in the chat box. Please check. You can code this darknet from scratch also. but it's a quite big code. If you want to do it from scratch, it's quite big. So that's why we are doing it from the actual, we are accessing the actual code from the official repository. So from the shared folder, just download 10 PNG files and 10 .txt files, because otherwise it will take a lot of time and data also. For further practice, you can access the complete dataset with 1600 images. So to perform changes in this make file, either you can download this make file from your drive. You can go ML4CV. Here you will find darknet. And then inside darknet, make file is there. This is the file. You can download it, open it in a any type of editor, notepad editor or any other editor, and then perform the changes in initial some lines. The changes are, we have to enable GPU, we have to enable CUDN and OpenCV. So instead of doing that part, uploading and downloading, we are changing it from SED command of Linux. So please write SED-I. What it will do, it will search for GPU is equal to 0, and then it will replace it as GPU is equal to 1. Let me run it. So I have executed it. I am pasting it in your chat box. This is the way you can enable GPU in your system. In the same way, I'm enabling CUDNN and OpenCV also. Sir, I'll explain you how you can add more layers in Yolo v4, how you can customize darknet framework. But let us first do these steps. So I'm giving you a minute so that all of you can do the same. If you are done with changing this GPU, CUDNN and OpenCV, report it in the chat box. Can we proceed further? So there is a question, we have already enabled the GPU, why we are doing it again. So we have enabled the GPU in your notebook, but to make it compatible with your code, you have to tell the code that you are working with GPU. So the code will be according to your GPU. Okay, so you have done with this part. Next part is you have to create one executable build file of this darknet, which you have downloaded from GitHub. For create the executable file, you have to run make command. Please run make command, and it will take some time. I request you to please comment these lines, this SED lines, please comment it with control question mark or just write hash before the code. This is needed only once. That's why we are requesting you to please comment these lines. When you run the code next time, the same code, if you want to run for the same data set, then it is not needed to rerun the code. These lines are not required. Because once you have updated the things in a file, it will be for upcoming time, it will be enabled. It may take some time. Please do it. Yes, when you run the code next time, these lines which are running, which are commented currently, will not be required to execute for the next run. Because whenever you are running any object detection algorithm, it takes time, maybe 2 to 3 days to run the code successfully to get the best results. So it is not possible to get the result in a single day, and Colab provides you only 12 hours of GPU access at once. So if you get disconnected due to some internet glitches or any other issue, then also you have to rerun this part from scratch. So these commands are not required at that time. So that's why we are commenting it. So you can see in my case, make command has been executed successfully. I'm commenting this make also. You can also do the same. If you are working, there is another question in the chat box that if we have our own GPU, then if you have your own GPU, then also these commands are not required to run again. So let's go ahead. Now, next step is please upload your data. So inside, go to your drive. Inside this darknet, which you have mounted, which have these files and folders. So there is a query from AICT HTTP 552. I'm not able to get it. You have pasted the code. So participants, let's upload the data. Inside the darknet folder, create a new folder with name, either name, you can create any type of name. I'm creating the name as smoke data. And then I'm going to upload the files, images file and corresponding text file. Let me upload 10 images and 10 text file I'm uploading. And be careful whenever you are working with custom data, your text file name and the image name should be same. The dataset file we have already shared in the chat box. I'm again pasting it. Please download 10 images. Sorry, I think I have pasted. Please download 10 images and 10 text file from the shared folder. Or let me do one thing. Just download initial 20 files from 1.png to this 10.txt. Please download these images and text files and upload it in your data. So you can see in my case, uploading is currently under process. It will take 2 minutes. So meanwhile, let's do the next step until the data is uploading. Whenever you are working with darknet version of Yolo, what you have to do? You have to make the changes inside some structure of the darknet file so that it will be compatible with your custom data. Other thing is you have to provide two more files. One file is the names file, which will have the class name of your data, and one is a names extension file. Class extension file. The file we will create now. So inside darknet, go to your Cfg folder. So there is a question that please repeat the process. Meanwhile, the data is uploading. We will do the required process to create the necessary files. So the first file is .names file that will have the class names available, and the second file is .data file that will have the information of where your class file is present, where is your training images and test images are available, and where you want to store the intermediate weights of your darknet structure, the trained structure. So to enable your darknet structure with the custom data, you have to perform the changes inside the CFG file. So inside your darknet, you can find out CFG folder is there. In CFG folder, you will find out this Yolo v4.cfg. This is the complete Yolo v4 architecture. If you want to work with the part of the Yolo v4, then you can work with this Yolo v4. It is a small Yolo which have less number of layers. So I request you all to please download this Yolo v4.cfg. Please download it. So when you have downloaded this Yolo v4.cfg, your file will be something like this. Now we have to perform changes in this file. Before that, please respond. Can we proceed with the changing in this file? Because it's little like confusing. So that's why I'm asking, if you have done this part, then only we will proceed, or we can wait for, so that you can download the same file. Have you downloaded the CFG file? Am I audible? Shubhangi ma'am, am I audible?
Yes, ma'am. Yes, ma'am.
Because no one is responding to that.
They are not replying actually.
Yes, ma'am. Thank you, ma'am. Okay, so if you have downloaded the CFG file, please open it in any type of editor. Then we will perform the changes. So these are the necessary changes. If you will make anything like not the same, then it can cause error while executing the code. Request to wait. So it's already 3:30. So Shubhangi ma'am, can we take a break of a minute? Then we'll start from here. Ma'am is not here in the, I think, in the meeting.
Yes, ma'am.
So participants, let's take a break of a minute. If you have any query related to this part, you can ask, then we will perform the changes. Those who are not able to download it, they can download, and those who want a break of a minute, they can take, then we will proceed. So we'll start in a minute so that all of you will know how we can proceed further. So those who have uploaded the whole data set, I request you to please use the part of the data set, either 10, 20, 50 or 100 images only, and corresponding labels. Don't use the complete data set. I will share the link of complete data set as well as the official data set, so that if you want to use the same data set in somewhere in your project or research work, you can use it. But it is not possible to process the whole data set here. That's why I'm requesting you to use the partial data set. So here in this Yolo V4 folder, you have to perform the changes. The very first change is take your batch size. It should be 64. Can we proceed? Participants? Okay. So first thing is, batch size should be 64. Subdivisions, change it to 16. The subdivisions are the division of your batches. In a single batch, we will process 64 images, and each batch will be subdivided in 16 images. Next is, this is for training. After that, it is asking for width and height of the image you want to process. So let's process the image with 416 cross 416. The input image you can change it. If you have a large size image, you can make it larger. So I think these are the small changes. First batch size, then subdivision, then width and height. So there is a query. Is it necessary all images should be of same dimensions? Yes, it is necessary that all the images should be of same dimension. Next, you can see it is asked like the next parameter is channels. What will be the depth of your input, momentum, weight decay process, what is the angle, saturation point, exposure, hue, the learning rate. Multiple options are there. Then you have to go to line number 19. It is having the parameter maximum batches. So this Yolo V4 notebook is basically built for the COCO dataset, which has 80 classes in it for object detection. But here in this case, we are working with smoke detection that has only one class, smoke. So accordingly, the maximum batches we will change. So the maximum batches should be 2000 multiplied by number of classes. We have one class, so it should be 2000, but as per the Yolo V4 restrictions, the maximum batches should also be minimum 6000. So in place of 2000, we are writing 6000, but actually the formula is 2 into number of classes. Kindly do the same. It should be 2 into number of classes. Next is you have to go to line number 21, which will have steps involved. So you have to change it to 80% and 90% of maximum batches. Maximum batches are 6000. So the first will be 80% of 6000. That will be 4800. And this will be 90% of 6000. So that's why it is 5400. Kindly do the same. Since the maximum batches as 6000, step should be 4800 and 5400. After this, the changes we have to perform is two very important changes. First is change the classes. When you search for classes, just search for classes. As Yolo is a quite big network, it's a large code. Just search for classes. You will find line number 968, which have classes equal to 80. Make it 1. Again, at 1056. So you have to replace classes equal to 1 at 3 places. Please make sure you have changed classes equal to 1 at 3 places. Line number 968, 1056 and 1144. I'm waiting for you all. Please do the same. Whenever you are done with this change, please let us know. Only one more change is required. So there is a query that please repeat the change after line number 21. Because you have one class. If you are working with the data which has maybe 100 classes, so accordingly here 100 will be written. I think we should move further. Can we proceed with the last change? Up to now, what we have done, we have checked whether batch size is 64 or not, subdivision is 16 or not. Width and height we have changed as 416. Then we go ahead with the maximum batches at line number 19, which we have changed as 6,000. It should be 2 into number of classes, but it also should be at least 6,000. If you have 10 classes, it will be 20,000. Accordingly, maximum batches will be changed. Similarly, here in line number 21, the steps are 80% of maximum batches. So 80% of 6,000 will be 4,800. This will be 90% of maximum batches. That will be 5,400. Next change we have performed is changing the classes as 82 classes as 1 at 3 places. Then the last change is changing the filters just before the Yolo layer. So you can see this is Yolo layer, which classifies your which perform the classification and localization, both the tasks. So just before the Yolo layer, there are filters available. You can see when you search for classes, that is there in Yolo layer. Just before the Yolo layer, filters are there. Filters with 255. Number of filters are 255. So we have to change these filters. So the formula to change these filters are it should be classes plus 5. The formula is classes, number of classes you have, plus 5. I will tell you why 5 multiply by 3. So why we have 5 here? When you talk about YOLO annotation, so let me explain now. I have not explained this part so that it will be better to explain here. When we are actually working with the example, you can see this 0 is there. This 0 represent the very beginning, the first 0 represent the class index. Suppose you have 10 classes. So class number 1 be indexed as 0, class 2 will be indexed as 1, like that. The index will go up to 9. And suppose your suppose the object first is there in your image on particular location. So that's why the first value is class label. Then there are remaining 4 values available. You can see. So it is the height, width of your image and the minimum value, the center value of your box. Is it clear to you all? This file contains 5 values. First is the class index, then height, width of your image, the bounding box, and then the X center and Y center of your that bounding box inside the image. So these are the 5 parameters we have to calculate. This is class index. So this is a classification problem. The first one is. The other 4 are the particular numbers, floating point integers, floating point numbers. So that's why we need these as, we have to work these as regression problem. So in there is a query that how to calculate the center value. So center value you can calculate, it's a basic formula. Whatever the value of y, the length of your x-axis, just divide it by 2. So you will get the center of your x. Similarly, to get the center of y, divide it with 2. So like that, you can get the center of your box. It's a mathematical formula, basic maths. So these 5 things you have to calculate, which here you can see these are 5 numbers. So that's why we are using 5 here. Classes plus 5 and multiply by 3 is here because we have when you see the YOLO structure, it is proposing 3 anchor boxes. So that's why we are multiplying it with 3. So we have one class, 1 plus 5, it will be 6, and 6 multiplied by 3 will be 18. So that's why the filters here will be in place of 255, it will be 18. Again, just search for classes. Here we have changed filters as 18. Again, just search for classes. You will find out this is the classes, and here the filters are 255. Whenever you will find that the filter is 255, just before this YOLO layer, make it 18. Again, this 255, I'm making it as 18. So you can see we have performed the changes of filters from 255 to 18. I request you all to please do the same. I'm waiting for you all so that you can also do. When you are done with this process, report it in the chat box. Then we will process with the next step. Is there any query till this part? Updating the CFG file. So I've pasted the link of the complete dataset. If you want to work with the entire dataset, it is there in the given GitHub link. You can use that wildfire. Please save it, or you can rename it. I'm saving it as wildfire.cfg. Just save it as wildfire.cfg. Then you will find out that this is the modified file. Let's go ahead with the uploading of this file. So you have to upload it inside the CFG folder only. Please upload it. Upload the CFG file. Next is go to your data folder. Here we will upload the other two required files. So let us first create the files. I'm creating a new file in my local system. The first file we are going to create is .names file, which will have the class name. So that also you can create for your data set, any of the data set object detection. I'm making it as smoke because we have one class. Suppose you have more classes, you have to write the class name in the next line. Fire. Like this, you can create a number of classes. So whenever your file will be read, it will read smoke as 0, fire as 1, water as 2, like that the indexing will be there. It will read it automatically. In case of this data set, we have only one class, so I'm writing it as smoke. And then I'm saving it smoke.names. Please do it. So after successfully execution of these files, we will share these names in CFG file after modification in the chat box as well. Next is please create a new file. The file will have the data value. It will have all the details of where your names file is there, where you will have the training data, text data, and backup file. So it will have the first, it is names, smoke.names. It is smoke.names. Please write S just after your. Then we are creating another file which will have the extension is data. So the first line is classes. We have one class, so I'm writing classes equal to 1. Then where your train file will be there. So we are going to create the train file inside data folder. So data slash train.txt. Similarly, test file, it will be there in data slash test.txt. Then here in place of test, we have to write valid. I think we have to write valid here, the validation data we are going to use, or that is the test data actually. But the parameter we have to pass, the variable name is valid as per the Yolo configuration. So we are writing valid here. The fourth line we have to provide is where is your names file. So names file is there inside data, and the name is smoke.names. And where you want to store the intermediate weights, the train weights. So that we will store inside the variable is backup, and we will store it inside backup folder. So backup folder is there inside darknet. If you are getting a little bit confused maybe, so that we will demonstrate it how the weights are updating and storing. So as per the Yolo structure, when your execution is done for some 100 iterations, then your weights will be saved in the folder. If you have time today, please run the code for maybe 500 or 1000 iteration. Then you will see that the results are quite good. I'm saving it as smoke.data. Pasting the lines in the chat box, use the same. Waiting for you all so that you have also created these files. Then after a minute, we will proceed. So the file updation process is done. Next step is we have to create the train.txt and test.txt file. So can we proceed now? Okay, let's proceed further. Next is we have to upload these smoke.names and smoke.data inside the data folder. Go to your data folder. You can see inside darknet we have data. Upload these files inside data folder. Smoke.data and smoke.names. Just upload these files. So what we have done, we have uploaded the data inside this smoke data folder, some 10 ng images and 10 text files. So whenever you are working with darknet version of Yolo, it is written for PNG files. If you are working with JPG files, then you will see that your code is not running. At the end, you will find out that your code is not running. There is no issue with the code, but that is because darknet supports only PNG files. So make sure whenever you are working on your custom data, your images should be in PNG format. Other thing we have done is we have uploaded the CFG file. I'm just repeating it so that you can make sure that you have followed the same process. Next is we have uploaded this wildfire.cfg. And then inside the data folders, we have uploaded smoke.data and smoke.names. Next is we have to create the training files and test file. So for that, we have to write a small size of code. Let's write it. Import globe. I will paste it. Import OS. And then data directory is, what is your data directory? It is, I think, let me check it. It should be smoke data. So this is the directory, smoke data. It contains the data. We will give 20% of the data for testing. So we are going to use test percentage as 20. Then we will create two files. One is train file that we can do directly using open function. Open function is there in Python that creates a new file in the current working directory. So instead of current working directory, we will make the file inside data folder, data/train.txt with write enable accessibility. Similarly, we will create a test file inside data folder. Then we are making one counter. And then we will check that the every like eight images should be there in training and 2 images will be there in test. And if you have 100 images like that, initial 8 images we will assign to training and 2 images for testing, like that. 2 for test, 8 for train, like that. We will store or save the images. So test index we are creating, it will make sure your test data should be uploaded, created inside the test file. So what will be there inside test and train file? It will have the path of your images. We are working with some 10 images. So 8 images path will be there in train file and 2 images path will be there inside test file. So to make it, we are creating a index, test index with round function. What it will do? It will divide 100 by the test percentage. And what we will do next? We will check that the test index should be equal to count. If it is equal to count, then it will make sure that the file should go inside the test file, test.txt file. The path will be there in test.txt file. So for file in globe.iglobe and then os.path.join. This globe.iglobe will give you the path of all the files inside the data directory. Which have all the PNG files. We are excluding .txt file because in smoke data folder, the .png files and .txt files are there. Both the files are there. So we are working with only .png files. Then what we will do? We can access the file name from this file and file extension as well. So os.path.base name of this file will give you one base. It will return you base name and the extension with when you split it. Let's split it. first of all, we'll get the file name and then we will split the file name and extension so that we can access the name of the image. os.path.split text it will give you title and then the extension. 2 variables it will return. Then we will check if our counter variable is equal to this test index. If it is same, then we will reset the count as 1. And what we will do? We will write the file, the test file, we will write in this test file dot write. The path is smoke data plus or we can write smoke data plus title plus .png, and then we will change the line so that the next path will be there in the next line. Smoke data, the path is smoke data plus the title, that is the name of your file, and then .png is the extensions of that we are writing, and plus /n so that it will write the data in the next line, next data. And for else, in file dot write smoke data / title .png /n, and then we will increase the counter by 1. Let's check whether the code is correct or not. So for that, we have to go inside the data folder. Print. Let us print the title to check whether the code is correct or not, or if there is any issue. Okay. Now you can see one train.txt is there in my data folder. And one test.txt is there. I'm pasting the code in the chat box. Please do the same in your code. This is the last step. Then we will train the model. This is the last step which is required. Please run it. Make sure your files are there inside the data folder, train.txt and test.txt. Another thing we have to make sure that it should have some file size. As you can see in my case, 128 bytes and 33 bytes files have been created. In the same way, in your case also, these files should be there. So whenever you are done with this part, you can report in the chat box, or if you have any doubt, you can ask. So participants, can we proceed? If you are done with this part, please report. So till this part, what we have done, we have cloned the darknet folder from GitHub, the official code. Then we have uploaded the data inside the darknet folder. We have created the executable build of your darknet code. Then we have downloaded the Cfg file from the Cfg folder. Inside the Cfg folder that has the configuration of various Yolo versions. Let me show you that what are the other versions. Meanwhile, you are working with the code. So you can see Yolo v4, custom CSP, Yolo v4 CSP, Yolo v3, multiple versions of Yolo v3, v3 tiny, Yolo v2, v2 tiny, tiny for VOC dataset, Yolo 9000, Yolo 2, VGG16 based Yolo. Okay, so if you want the modified files, I'm uploading the files. I'm uploading the files in the chat box as well. Wildfire.cfg is there in the chat box, smoke data and smoke names. Please respond. Can we proceed further? I'm again commenting this code because it is not needed again. Next is we have created the data and uploaded in the our folders, respective folders. We have to make the files, those created files, compatible with the Linux environment, because the text files created inside the Windows are not compatible. The codes are not, files are not as same as Ubuntu files. So in Ubuntu, there is a package named as DOS2 Unix available, which converts your DOS or Windows-based files to Unix compatible files. So let's install that. This is a Ubuntu command. Sudo apt install DOS2 Unix. Okay, I have to write exclamation just before sudo. So you can see now the package is installed. I'm commenting it in. Then I will run the next. I'm pasting the command sudo apt install DOS2 Unix. This is the library or package we are going to use to convert the uploaded file compatible with Unix or this Linux version. So DOS2 Unix, then you have to provide the path. data slash train.txt, data slash test.txt. Inside the data, we have smoke.data. Inside the data, we have smoke.names. And then inside CFG, we have wildfire.cfg. So the result will be something like this, converting file to Unix format. So participants, is there any issue? Are you able to do it? Because today I'm not getting like response from you all. Or it is, I'm not able to explain you in a proper manner. So if you will respond accordingly, we will update the process. Because this is not the earlier lab we have done. Next is, we have to train our Yolo model for the smoke dataset. So for that, we are working with like fine tuning from or training from the weights we got from the Coco dataset. So let's first of all download the weights. So for that, I'm again writing another Unix command, that is wget. The path for the weights are, let me go with the Yolo V4 on 137 LXAV. So these are the weights. It is downloading in my system. I have to stop it. I'm just copying the path. And I'm pasting the path in the chat box. You cannot maybe copy it, but by clicking on the link, you can at least open it. So we are going to use these weights. So just write wget and then the weights. So it will download these Yolo V4 weights for this particular model. And then I request you please comment it again because it needed your data. It is a 42 MB data. So it requires internet. You can download and then upload it in the drive. But we are following this wget process. I'm pasting the entire syntax. Next is the training. So it's a simple one-line code which you have to write to train the model. If everything is perfect, your name, file, text, the test train.txt, test.txt, and the data file, Cfg file, everything is well. You have the PNG images. Then your training will start now by writing a single line of code, that is ./darknet. So what is this ./darknet? It will read your darknet file that is inside the darknet folder. When you go inside darknet folder, there is a file darknet. Let me show you. This is the there it is. This is the file, darknet file, which we are going to execute. So inside darknet, what we have to do, we have to call the detector. For which process we want for training. So darknet detector train. Then we have to provide the path of your data file. So data is inside data/smoke.data. Next, you have to provide the path of configuration file that is inside Cfg folder. Cfg slash, I think it is wildfire.cfg. And then the weights. So weights are these. Yolo v4.con.137. Yolo v4.con.137. And then another parameter you have to pass is don't show, because we are working on collaboratory, it will not pop up your results. So this parameter is mandatory. If you are working on local system, you don't need to pass this parameter, then also it will work. So if everything is well, your model will create. If there is any issue, you will find out that if after this create 6 permanent CPU threads, your process may stop. So make sure your images are in PNG format. You have converted the TXT file with the compatible Ubuntu files, then only the process will work properly. So you can see it is checking, first of all, it is reading the CUDA. So in this case, CUDA is 11. CUDN is 7.6.5. The GPUs available for this process is 1. The OpenCV version it is using, then it is reading the file. Then it is checking, it is reading the structure from this CFG file. So this is the structure. Then some more hyperparameters, and here you can see it is allocating the CUDA. Now the training has started. I'm pasting the code in your chat box. Please run the same and report. Here we need your response that are you able to run this training process or not? Because if you are able to run it successfully, then if you want to use it for some other data set, then also it's quite simple once you are able to run it. So initially you can see this is first iteration it has completed. Second, then it is this is the loss. As Yolo v4 is built upon, it is writing v3 here. Then the IOU loss. It is writing the IOU loss. This is the loss of this iteration. This is the loss of average loss of the complete iteration of first and second loss. This is the rate on which the it is changing the weight update, the time taken, number of images, or the location it is working with, how much time it will take for complete training. So now you can see, in my case, the process is working. So generally what happens if you run for some 100 iterations or 100 epochs, 100 iterations, then you will find out that you are getting some good results. To get the best performing result, maybe you have to train it for some 1000 iterations with the complete data set, not these 10 or 20 images. So anyone who is able to do this, please respond in the chat box. Are you able to run this training process? Participants, please respond. Are you able to run it? Or there is any issue? So there is one query that your execution stopped at some point. Okay, for someone it has crashed. Let me do one thing. Sir, can you please share your screen? One by one, please share your screen so that we will see what is the issue, because I cannot answer without. Okay. So you can see the error is allocate addition workspace size this. Loading weights from Yolo v4 don't show. That means wget file. Can you please scroll up? This wget, please run it again. This line number 20. Run this wget cell again. Okay. And scroll down. It is Yolo v4.com. Please give us space just after 137. There should be one space. Now run it. Then it will run. Now you can unshare, sir. Now the training will start. Next is, I think, Ravi Surendran, sir. Can you please share your screen? And then the third is Dell, maybe, I don't know your name. You can also share, please, so that we can help you. Okay, working in Ravi Surendran, sir, in your case. Anyone else? So what I'm doing, I'm stopping this training process here, and then I will show you some more commands. As it is not possible to train it within 2 hours, so definitely the results are not quite good. But if you will run it for some 100 epochs with the complete 1600 images, you will find out that the results are good. The next is, generally your weights are saved here. Inside the darknet, there is a folder backup where weights will be saved over here inside backup after 100 epochs. So in my case, I have the weights inside another directory, sorry, inside another drive. You can see these are the weights, smoke Yolo v4 last dot weights. So these weights are there inside backup folder. When you train with 100 iterations, then you will also get the same weights inside backup. Sometimes what happen after 100 iterations, your process will stop, or maybe 110, or maybe after 500 due to some internet glitches, you can get disconnected from collaboratory. Then you can restart or resume the training from there only. The command will be same as the earlier one, only change is in place of this YOLO v4, you have to give the path of the trained weights. Inside backup, the weights will be wildfire underscore last dot, maybe it is weights. So currently I don't have the weights, so it may give me error. I have pasted the link. So somebody is asking for quiz link. So I think ma'am has mailed that those who have missed the quiz, they can access the quiz tomorrow at 4:30 p.m. Not today, I think so. Because tomorrow is holiday. The link is there in the shared sheet, or I don't know. The link we will again share in the same sheet. If ma'am will change the quiz, then we will share the link in the same sheet, shared drive. I don't know whether the link is same or not. Let me tell you one more like prediction example, and one more command, then we will end the session. So if you want to predict on unknown images, if you have some image and you want to predict on some unknown images, so in place of train, it will be test /darknet space detector test, provide the data file, Cfg file. These are the files you have to provide. And then the backup or the weights. So currently I don't have the backup. I will use the existing weights. And then you have to provide the image. So 1.png. The recordings are already there in YouTube. Just search for Oja ma'am's name with the Oja ma'am name on maybe I think on YouTube you have to search for Oja ma'am name, and then you will find out that the YouTube link is YouTube video is there. So you can see it is predicting the smoke. Currently it is not predicting correctly. The reason is you have not trained the model successfully. Your results will be there inside darknet folder. One prediction.jpg will be created. Your results will be here in this image. Okay. So these are the predictions it is doing, but please train it for some more epochs. Then you will not find out any overlapping box. The results are as accurate as these results. We have the results. These are the results from the whole data set. So these type of bounding boxes will be there with the probability. You can see 0.8 is written over the smoke. Here also is with the probability 0.51, it is smoke. With probability 0.73, it is smoke. So till this part, anyone having any issue?